It's wonderful to see everybody in person again. It's been a long time since we've had one of these events, and it's wonderful to see familiar and new faces as part of the Ceph community. So today, I wanted to talk a bit about the state of the Ceph project, what's been going on recently in the latest releases, what we're planning for the future, and some of what's happening overall. It's been several big years of growth for the Ceph community in general. We've changed to a new governance model for our technical governance. Instead of having kind of a single person stage while we've had the project, we've moved to a model of a council, as Mike mentioned, and a shared leadership with the leads of the different components of Ceph. So the leads elect the council every couple of years, and the council is responsible for making sure everything else basically happens and taking care of the community as well, with the help of Mike and the Ceph Foundation. A few major focus areas for us in general have been quality, performance, and scalability, in addition to usability. So we've been doing lots more testing at large scale, trying to detect things before users hit them, and improving our processes, like creating RC releases that users can test out at large scale before the final release hits the ground. We've also been focusing much more on performance testing and performance improvements in Ceph. A big part of that is the Crimson project, which we'll talk more a bit about later. But this also means trying to run at much larger scales and much more varied hardware on a more continuous basis with more realistic workloads. Finally, we're also looking to see more about how Ceph is used and get more continuous feedback from the community. Part of this is the telemetry effort, which Reef will talk more about later. We have this is all opt-in data reporting that you can share anonymously how big your cluster is, how many OSDs it has, these sorts of information. And right now we have somewhere north of 800 petabytes of Ceph clusters reporting. There's a massive amount of users out there. These are all, you can inspect some of the data that's out there in the public telemetry dashboards, which we'll talk more about later. And for the developers, there's some private dashboards where we can go and see, for example, if we just did a release, how many crashes are happening, which clusters is it affecting, is it only a one-off incident or is it widespread, that sort of thing. So in terms of releases, we're midway between Quincy and Reef. Originally, our plan was to release Reef in March, but due to some lab outages this year, we pushed that back to June this time. So as before, though, we're continuing with the yearly release process, doing a major release each year, and deprecating the release 3 years away. So after Reef is out, Pacific will become deprecated. So let's talk a little bit about what's going on in the project. What are the technical features and the improvements we're making in Quincy and beyond? So as I mentioned earlier, performance and scale has been a big focus area for us. We've been doing lots more testing at a number of different clusters. One of the major ones was the supercomputing center in Australia, the Poly Supercomputing Center, which allowed us to use a very large cluster of theirs for testing out and fixing a number of bugs in CEPHADM and other pieces of Ceph, including the manager, at a very large scale of thousands of OSDs. We're continuing to work more with them again this year and hope to do similar kinds of testing before the Reef release. We're also trying to do more logical scale testing on our upstream lab, which is not as large. We can't run thousands of OSDs and use that full space, but we can run thousands of OSDs with a much more limited amount of resources and space. So we're developing some methods to actually test out things you see at scale without needing the full scale of data. Finally, there's also more focus on performance as well. And in performance, it can be a very interesting thing to test. There are many different aspects of this. One of them, a lot of the things you can test for performance actually end up showing up even at smaller scale. So we have a much smaller scale set of high performance nodes in our upstream CPO lab, and we're always improving and looking for more help with running tests there. Currently, I think we have, what is it, something like 16 or so nodes, Mark? Right, so we've got a few different clusters of a mixture of Intel and AMD processors and a mixture of different manufacturers' fast NVMe devices. And we're continuing to try to improve that testing and maybe even make it into more of a continuous process rather than a kind of one-off manual test effort. So within the RADOS layer, which is the base layer for everything in Ceph, there's been a lot of focus on stability and reliability. So one of the major things there is quality of service, being able to maintain the performance of the different clients versus when different things are happening inside the cluster, like you have lots of scrubbing going on to check for data integrity, or lots of recovery from a failure. You want to keep your clients happy and keep the latency and throughput going as you expect. So in Quincy, this was made the default. We have a new scheduler called mClock, which implements this quality of service for background operations. We made further refinements to it that are coming up in Reef. And right now, it's only for background operations compared to clients. But in the future, we're going to extend it to be supporting different classes of clients, so different clients can have different reservations for amount of IOPS they want, that sort of thing. We also tried to make this relatively easy to use because Ceph has many, many options for tuning these kinds of things today. So with the mClock scheduler, instead of setting tens of options to figure out how fast you want recovery to go, you just choose a single profile. Do you want recovery to go faster? Do you want clients to go faster? Or do you want something in the middle? It's always possible to go deeper and configure things at a much lower level than that, but we're trying to keep things simple to manage and maintain. So if you don't have to carry about all those nitty-gritty details of thousands of configuration options. This also applies to some of the other improvements we made in RADOS, but in terms of how we're reporting health errors and how we're reporting slow operations. We're trying to make it easier for folks to diagnose performance issues and stability issues in the cluster sooner. I think we'll see some more improvements there in the future as well as distributed tracing gets more embedded in the different protocols of Ceph. Reef will be the first release where that's going to be present and easily deployable. So also coming up in Reef, there are lots of more improvements for BlueStore for performance purposes and also potentially addressing different kinds of performance problems that can show up like fragmentation. This has been a major cause of issues in BlueStore in the past, and there are some thoughts around improving the way the allocation algorithm works in BlueStore to prevent this from happening or enable it to be handled during scrubbing so that you can deal with it if it does occur without having to redeploy OSDs, making it all much more automatic. Becoming more automatic is the general theme that we've been striving for in RADOS, and another aspect of that is improving the balancer, how we're distributing data across the cluster. So today the balancer works only with looking at purely the capacity used on each OSD and moving it around to try to even things out. In Reef, this also includes balancing across the primaries because when Ceph is doing reads and writes, reads are always going to the primary OSD. So if you have a skew in how many OSDs are primary for a certain number of objects, you're going to see hotspots. So now the balancer will take that into account as well. You should have even more even performance. One of the major focus areas for Ceph and performance is the Crimson project, which is a re-implementation of the OSD in a new architecture, which is shared nothing, meaning it's designed to avoid any kind of cross-CPU or cross-thread communication, so to go at the maximum speed from the wire to the disk. This is in the experimental stage right now, where it supports the basic operations of RBD, but it's still undergoing stabilization and has a long way to go in terms of optimizations before being fully production ready and being able to be used for all workloads. So in Reef, we have some initial support for multiple reactors and snapshots, but we're continuing to build out the test suite there and continuing to improve the functionality to make it fully able to be used for RBD in the next release, probably S. A big aspect of that as well is the C store, which is a new store backing the OSD designed specifically for high performance systems like NVMe disks and other sorts of very high performance media. This is also in an experimental stage right now and has a lot of room left for optimization and stabilization. But we should see this come to production hopefully in the next few years. So as I mentioned earlier, we have this telemetry system, which is all opt-in reporting. We're trying to make this easier to use and easier to update. So we introduced a number of notions around how to manage the data there. I think Yurit's going to talk a bit more about this in more detail later, so I'm going to skip through this pretty fast. But essentially, we're gathering both metadata about clusters, crashes that happen, and also information about drives that fail, so that we can feed that back into models for predicting failures before they occur. One major aspect of usability is the interface for Ceph, and the dashboard is the easiest to use UI for it today. So in Quincy, it's much easier to manage things like expanding the cluster, adding new hosts, removing them, and it's gained support for a number of different protocols like monitoring protocols and adding proxies to be able to make things HA. In Reef, it's expanding the support across different functionality in RBD and RGW especially, and trying to make things easier to monitor and easier to diagnose by integrating the centralized logging in as well. So you can have all your logs go to a standard Elasticsearch based platform to inspect and sift through. CEPHADM is the current way to deploy our clusters with Ceph, which is designed to be as easy to use as possible. It's deploying them via containers and systemd, but managing it all through the Ceph orchestration commands, which are common to both CEPHADM and Brook, which is the deployment method on top of Kubernetes. CEPHADM itself has gained support for a number of different things in Quincy. And in general, we're trying to make it easier to use and easier to deploy in flexible ways that people would like to. So in Reef, we're also making it simpler to upgrade more piecemeal so that you don't have to upgrade the whole thing at once. That was a little bit more difficult in the past. Making it simpler to set up multi-site deployments for the RADOS gateway and for mirroring with RBD. And we're also added support for automatically rotating the keys for authentication for Ceph daemons, which keeps your clusters secure. So Rook is the main way to deploy Ceph on top of Kubernetes. And Rook is always catching up and keeping up with new features in Ceph and new features in Kubernetes. So now it's supporting much easier ways to troubleshoot a Ceph cluster. I believe there's even a new project a little bit separate from Rook to kind of gather some of these troubleshooting commands together in one place to make it simpler to diagnose and to inspect a cluster deployed in a Kubernetes environment. There's also now support for more NFS operations. So RBD, the block device portion of Ceph, is one of the most popular uses for it. It's been very stable for a long time, and now we're starting to see much more interest in more advanced protocols and more advanced functionality with it. So there's a large effort around the NVMe over Fabrics protocol. Currently, the work there is around a gateway, which Jonas was going to talk about after me, I believe. And in the future, I think this will be a large and important protocol for Ceph because it's becoming a very widely supported standard and a very easy way to connect to all kinds of operating systems and hosts. There's also some performance improvements within libRBD itself. Support for a caching daemon that does write back, contributed by Intel, designed to take advantage of very fast local storage if you want to have writes going through a single disk locally before being pushed back to the main cluster. And finally, we're focusing a lot in RBD on the multi-site capabilities there, asynchronous mirroring, namely, between multiple clusters. So this is important for disaster recovery. And there's a lot of work going on to harden and stabilize this and make it perform well at a large scale. Interesting research in the future is ongoing from a group at Northeastern University into a log-structured format for RBD, which has the potential to drastically improve the performance for random I/O in particular, but it has some restrictions on what workloads it applies to. I think it's a very interesting effort for the future. In RADOS Gateway, the S3 and object storage interface for Ceph has a number of ongoing efforts. A lot of these are around supporting AI and analytics types of workloads, like things like S3 select, being able to run SQL queries against your objects. This is a particularly interesting project because it's able to run standalone as well, so you can easily develop your queries against a local file and then run them against your cluster. Another big aspect for the RADOS Gateway is multi-site support. So it's supported different kinds of multi-site replication for a long time now. But there are some performance issues that we're looking to address in Quincy and Reef, namely around parallelizing more of the work among multiple gateways and synchronizing things across and balancing that load across all the gateways. There's also ongoing work towards being able to debug and understand what's going on, namely with the Jaeger open telemetry tracing, which is now deployable in Reef quite easily via CEPHADM and I believe Rook pretty soon. This will let you debug where operations are getting stuck or where performance is slowing down, basically at each step of the way. So you can see if something is being synced from site A to site B, is it getting stuck, or is it slowing down at site A or at site B, or which part of it is going wrong if you have a problem. There's also a lot of work into the RADOS Gateway's zipper backend, which is a kind of pluggable backend to let you put different things behind RGW for different purposes. If you wanted to run it in a very constrained environment, for example, you could back it with a simple file or a simple database. Within CephFS, there's a lot of work on the CephFS top utility, again, for introspecting what's going on within your system from a performance perspective. So you can very easily see what clients are doing what, and if there's an issue, go in and look more deeply at that. There's also work towards cloning and snapshotting support, similar to what we have for the block device, where you're able to clone a subtree or files and easily make copy and write changes to those. And finally, there's some work ongoing towards better security via file system level encryption. The last piece I want to touch on is testing and quality in general. So there's a few different aspects to this. A new effort that we're looking to focus more on this year is the developer experience. If it's very difficult to run the tests for a system, it makes it much harder to add new tests and keep them maintained. So if we can create a way to run these tests locally, instead of having to wait hours for a build and push it through a queue for days, if you can run those on your own laptop or your own machine, it becomes a much easier proposition to contribute and to maintain those tests. In addition, making a easier to develop local developer environment can make it much easier and faster to develop if we can make it based on kind of an incremental builds instead of always rebuilding everything from scratch. So that's something we're going to see more improvements on coming up. As I mentioned earlier, there was a bit of a large outage in our lab that slowed down our release process this year. So we're making some improvements in our lab infrastructure to make it more resilient, and also looking to how we can run these kinds of tests in other environments in case there is a problem with one. Another aspect of that is engaging with other organizations that have hardware they'd like to help out the Ceph community with, and enabling them to contribute by running tests themselves on RC candidates, for example, or maybe providing some backup hardware in case our CPA lab has an issue. We need to get things going to be able to merge code and get releases out the door. And finally, as I mentioned earlier, looking into improving performance on a more continuous basis and monitoring it via a CI system instead of manually running performance tests on each release. So that's kind of what's happening with Ceph. Again, we're mainly focusing on performance, quality, and usability. And if you have any questions about any of these, feel free to ask now, or come up and find me later today. Mm-hmm. Yeah, so the question was, for the QoS for mClock, will you be able to do a fine-grained decision for a particular image? And the answer is yes. The idea is that you'd be able to apply a policy for how many IOPS this image gets, or you could make it on a per pool basis, or there are several different granularities, but the underlying support would be even at the image level. Any other questions? All right. Well, thank you very much.